Hi, Trino users. My name is YongHwan Lee, and I'm working as a data engineer at SK Telecom in South Korea. Today, I would like to share about the PTF for unstructured data analysis that our team has developed and is using. This is today's agenda. First, we will briefly introduce our company, then introduce the pain points of unstructured data analysis, and the PTF then can solve them. Afterward, we will talk about how we implemented PTF, our future direction, and have a Q&A session. SK Telecom is the largest telecom company in South Korea. We are a huge advocate of Trino and also are the first and only Starbucks partner in Korea. Over the years, various architectures have emerged in the field of data engineering. Starting with data warehouse, it has continued through data lake, and recently data mesh. Data warehouse architecture deals only with structured data. However, starting from the data lake architecture, there has been a change in the form of collecting and analyzing semi-structured and unstructured data in one place. However, for such unstructured data, there is no standardized format. So in order to use unstructured data, you need to write a program to convert it into structured data. Let's look at an example of real life. In the initial stage, we sample a few files and develop a pre-processing program in the local environment. After program development is complete, we deploy it into a production environment. Deploying a program to a production environment is not the end. There are many things to consider, including performance, operational convenience, failover, and notifications. Our goal is to transform unstructured data into structured data. However, most of the output is irrelevant to the purpose. Isn't it possible to query unstructured data directly without unnecessary processes? Since SQL does not support reading unstructured data, we added pre-processing. What if you could embed pre-processing within a SQL statement? Without pre-processing stage, we can read unstructured data immediately when we want. There is also no need for space to store pre-processing ledgers. Analysts only need to focus on how to transform the data and use it. To achieve this goal, we implemented the polymorphic table function for unstructured data analysis. Polymorphic table function is a user-defined function that returns a table or dataset. Polymorphic table function is defined in the ISO standard, and Trino introduced PTF in version 381. Trino has several built-in PTFs. Let's take a look at the form of PTF and why it is used, using query PTF as an example. This is the typical Trino select statement. There is a table identifier in the from clause. This is select statement using PTF. You can see that the from clause contains a function call rather than a table identifier. PTFs are left in a function named table to distinguish them from regular function calls. The table function contains the actual PTF function. PTF parameters are passed in key and value format. By using PTF, you can overcome the limitations of query processing or create entirely new ways to generate data. First, let's look at an example of overcoming the limitations of query processing using PTF. Let's consider Trino's predicate pushdown. We can expect to read less data from the source system with predicate pushdown. When the above Trino query is executed, a query containing a where clause is passed to the source system. Then the source system returns only data that satisfies the conditions to Trino. However, not all conditional expressions within the where condition are pushed down. For example, if conditions for different fields are connected with the OR operator, pushdown will not occur. As a result, a query that causes a pull scan is passed to the source system. If there was a way to force pushdown of conditional clauses, wouldn't it be possible to improve performance? What makes this possible is the query PTF. The query PTF receives a native query to be performed from the source system. Native queries written within the PTF are forwarded to the source system. Because all conditional statements are included in the query passed to the source system, a first pushdown effect occurs. PTF also allows you to create entirely new ways to generate data. By using sequence, a PTF introduced in Trino 414, you can create a set of numbers in a specific interval like Python's range function. So, what kind of PTF should we create to analyze unstructured data? First, the path of the unstructured data to be preprocessed must be received as input. Additionally, we must also receive Python code to preprocess the unstructured data. I expected it to be a function of this type. Before introducing the PTF we created, let's set up a usage scenario. Let's assume a company is running a web service. There will be multiple web servers running, and each server will generate logs. And the log collection agent will load it into the data lake. A collection agent can load only files to a specific path, or it can additionally store metadata about files in a separate table. Metadata information could be what region or host it was collected from. Finally, the analyst reads the unstructured data through a PTF containing preprocessing code. We created two PTFs that work in these scenarios. We will show an introduction, demonstration, and implementation of each PTF. The first PTF I will introduce is Python file query. Python file query is a PTF that receives the path of the file loaded in the data lake directly as an argument. Python file query is used when the collection agent loads only files into data lake without separate metadata. The statement for using Python file query can be written as follows. First, put the table function call in the from clause. Call the file query PTF inside the table function. The path of data to be preprocessed is passed to the files field. Both directory and file path can be used, and in the case of directory path, data is read recursively. The schema of the preprocessed data is passed to the returns field. The preprocessing code is passed into the field named code. Let's see a demo of using the Python file query. We will conduct a demo based on the scenario explained above. Okay. At the beginning of development, the analyst will download some unstructured files to the local environment. The input.bin file you see on the screen is unstructured data downloaded locally. You can confirm that the file contents are in the access log format mentioned in the scenario. Okay. Access log can actually be considered semi-structured data, but please understand that this data is used for convenience of demonstration. The analyst will write a Python script to parse the access log. I wrote a file called parse.py in advance for the demo. All right. Parse.py lists the input.bin file, parses each line using regular expressions, and returns in the form of dictionary list. And finally, it outputs this in JSON format. When you run parse.py, the access log is output in JSON format. I will demonstrate using this process within Python PyQuery. For the demonstration, we loaded the access log in HDFS in advance. Okay. And this is the same format as the access log we just parsed. Let's write a query using Python PyQuery through dweaver. We press. Okay. In the files field, enter the path where the access log was uploaded. In the code field, paste the content of the script we just created. And returns field, enter the parsing result schema in the returns field. I put it in advance for demo. When you run a query, you can see that the parsing result of unstructured data are input in the form of structured data. Let's simplify add one field. Let's add an event field with the value Trino Summit 2023. All right. And when you run a query again, you can see that the event field has been added to the result data. Okay. I will explain the implementation of Python PyQuery. There is not enough space and time to explain all implementations, so some flows and operation have been omitted. Please understand. What makes PTF different from regular table-based lists is that it adds the process of converting PTF query to the table handler. Once converted to table handler, it goes through the same process as a normal table-based list. Process number 2 in the picture represents this. Additionally, the leading process of our PTF involves taking an unstructured file as input, converting it to structured data through a Python process, and reading it. Processes 5 and 6 in the picture represent this. In the following chapters, we will explain in detail how each part shown in the picture above was implemented. First, I will explain the process of converting PTF to table handler. Although not shown in the picture, a connector table function object is created by receiving the input parameters of PTF during the analyze process. Afterwards, the apply table function method of connector metadata is called, and in this process, connector table function is converted to a table handler type. The PTF expression on the left is changed to the table handler object on the right, and in the subsequent process, source data is produced based on the information of this table handler object. Splits are created based on the path of the table handler. If the path is a directory rather than a file, subpaths are searched recursively to create a split on a file basis. Split also includes address information that tells you which node the file is located on to ensure locality. Unlike files such as Parquet or an ORC, unstructured files are characterized in that they do not require block-level processing because the entire file must be read at once. The split created in the previous step is passed to the worker. The worker first creates a temporary path and writes your Python code to that path. Afterwards, the files from the path included in split are downloaded to that temporary path. It then executes the Python code in the temporary path and reads the standard output generated by the process. We use the Java's process builder to run a Python process and read its standard output. When these records in the JSON format are returned in page format and delivered to Trino, the reading process is completed. The second PTF I will introduce is Python meta query. Python meta query is a PTF that references the path of the file to be processed through separate metadata. After reading the path of unstructured data files stored in the metadata table, based on that path, the actual file is read from the data lake and processed. The statement for using Python metadata query can be written as follows. Call PyMeta query within the table function. The schema and table name of metadata table are passed to the db and tbl fields. Pass the file path column from the metadata table into a field called path field. Finally, like Python file query, the resulting schema and pre-processing code are passed to the returns and code fields respectively. Okay, let's see a demo of using Python meta query. First, we will simulate the process of loading information about files periodically collected by the external program into Hive as a metadata table. We will create access log table consisting of a path field indicating the path to the unstructured file stored in the distributed storage, and UID field, which is the unique ID of this record. Okay. Then execute an insert statement below to make it appear as if 14 access logs have been loaded. Right. You can see access log metadata list. And now we will proceed with unstructured data analysis by referring to the metadata table through Python meta query. First, For DB and TBL, write default and access log respectively to point the hype.default.access log, the metadata table we created. And since pass field in the metadata table point to the path to unstructured data, enter path in a pass field. Lastly, as in Python file query, the code for passing unstructured data and the resulting data schema are entered in code and returns respectively. Okay, I will execute it. Yeah, the execution result is similar to Python file query, but you can see the fields of the metadata table: path, UID, IP address, access time, URL. Let's take a look at the implementation of Python meta query. In the case of Python meta query, only the coordinator split creation process is different, and the reading process in worker operates the same as Python file query. Unlike Python file query, which receives the path of the file to be read directly as a variable, Python meta query must create a split by reading the metadata table containing the file path to be read. Since the metadata table exists in Hive, it was configured by including a PTF handler with field information pointing to the user code and pass in the Hive table handler. The split creation process consists of total 3 steps. First, read the partition of Hive table. Second, extract the list of files contained in the partition. Third, the file is read in record unit and the values of required fields are extracted. The values to be read are the value of the field projected by the user and the value of the field pointing to the path to the unstructured file. In the third step, configure split with the values read. Split includes the unstructured file path, code, and metadata table field values. If you do this synchronously on the single thread, split creation will be very slow. This is because the response of the API that extracts partition list, directory listing, and file information is very slow. To solve this problem, we reference the background Hive split loader code to create a split in a multi-threaded asynchronous manner. Since the reading process in the worker operates as the same as Python file query, the explanation will be omitted. Additionally, I thought the process of inserting code into the PTF each time was inefficient. I thought it would be a good idea to save the code running in the PTF and reuse it. So we extended the Trino SQL syntax to create the create script syntax. Script contains your code and a list of result fields it produces. Let's take a look at a demo of PTF scripting. Okay, we will script the access log passing code we used in the previous demo. First, the name of the script will be set to parse access log. The resulting schema will be put into returns. It can be noted that unlike in PTF, it was implemented not to use a descriptor keyword. Finally, the code can be written by wrapping the S keyword followed by $2 character. Okay. You can use the show script statement to check the list of registered scripts. Okay, we can check the code and returns field. Now I will show you an example of using the script registered in Python file query and Python meta query. Create a Python file query as before, but remove the code and returns field and add the script field to use pass access log. When you run a Python file query, you can see the execution output result from code pass access log script. You can see that Python meta query also uses script to output execution result. Okay. Let's take a look at the implementation of PTF scripting. You can extend Trino SQL syntax by modifying the sqlbase.g4 file, which is the grammar file of ANTLR implemented in Trino. 3 statements have been added to create, modify, view, and delete script. When you execute create script statement, the content of the script are saved in JSON format to a specific path in the coordinator. If you later remove code and returns from Python file query and Python meta query and replace them with script, the script file is read before executing the query and is processed as if returns and code field are included, and PTF is performed. PTF development is still ongoing. In the future, we plan to perform tasks to improve the efficiency of the split creation logic, make user debugging easier, and process PTF predicate more efficiently. In addition, while using Trino, we are internally customizing parts that we could like to see added in terms of performance, functionality, and are working to contribute this to community. Lastly, I would like to thank Jennifer Orr for helping me prepare for the presentation, leader An Sang-hwa for always providing inspiration and advice, Emerging DP, our team members, and our partner Star Wars team for organizing the event. Yeah. Thank you for listening to the presentation, and we will conduct a Q&A. Thank you.
All right. Thank you, YongHwan, for that talk. That's really cool and fascinating. That was an interesting listen and a good demonstration of what you can do with PTFs. If anyone in chat has any questions, feel free to chime in right now. Otherwise, we do have a break coming up and we can cut to that. But I'll give it a moment. Sometimes people are a little shy with their questions. So we've got some positive feedback from Sunghyun and Rihanna. Josh Klum asks, how do you control resources and processes on the workers?
You know that Python process occupies its own CPU and memory. We now provide much more memory size in Node, more than Trino uses, and we will do some more tasks with the control resource and process it in future. But now it is just manually sizing. Yeah.
Yeah, that makes sense to me. Barring any other questions, I think I can say thank you, and we can go ahead and move into our break.